Okay, we're talking about the hyperbola is our next model. The standard form for that, listed right here. Oops, too far. Um, with the, you can easily see the center, and you can see the values of A and B that you'll use to create the edges of the box. And this has got a minus in between, so that's telling me, imagine taking the ellipse, cutting it in half. That's kind of the idea of what happens when you have a hyperbola. Now you can either have a positive x squared term, or you can have a positive y squared term. The positive y squared term opens up and down, and the positive x squared term opens left and right. The asymptotes are given by this formula. You'll notice it's the point slope form of the equation of a line, with the slope being b over a, plus and minus b over a, because you're going to have two different asymptotes. In order to find the foci would be found using, yes, the good old Pythagorean theorem. So that's what we'll use when we get to that section. Okay, so how would I handle sketching the graph of this hyperbola? I've got x squared. X squared minus over 25. Okay. So what I would want to do is find A. A is the square root of 25, or 5. B is the square root of 4, or 2. C is the square root of 25 plus 4, or the square root of 29, which is approximately 5 point something or other. Hold on a second. Clear that out. The square root of 29, we got 5.4. That'll be used to find the foci. Okay, so let's use our information on our graph. We've got our center. The center of this was at the origin, 0, 0. We noticed that when we looked up here at the x squared and y squared terms. We can use the 5 left and right, the 2 up and down, and we can create that imaginary box. Now, if this were an ellipse, we would draw the ellipse inside the box. But it's not an ellipse, and it would be really helpful if I had a ruler. But I don't have a ruler, so I'm going to improvise. The corners of the box, if I do this right, the corners of the box represent the asymptotes. Oops. At the edge of the box, since this is a positive x squared, this one opens left and right. So the first vertex, or the vertices, I should say, sit at the edge of the box on the horizontal side. If it was a positive y squared term, it would be opening up and down, but it's not. It's opening left and right. So one branch is coming this way, getting closer and closer to the asymptotes on this side, and the other branch is getting closer and closer on this side. Now, if the distance to the edge of the box at the vertex is 5, you'll notice that 5.4 is the distance to the focus. So that goes from the center out to 5.4. So one of the foci sits right there, so that's a focus, right? And then another focus is over here. So the foci sit at, in this case, plus and minus 5.4, comma, 0. Okay, that distance was used from the center to get to the focus. Notice that it each focus is inside the branch of the hyperbola, not inside the box like it was in the ellipse. In the ellipse, it was inside the ellipse, but also inside the box. Okay? The box in this case, while not a part of the hyperbola, just helps me identify the branches of the hyperbola, which will contain, it helps me find the asymptotes which contain the branches. I think I said that wrong. Whoa, what was that? Um, Everything else is the same as far as completing the square. Changing things to standard form looks an awful lot like the ellipse, so I'm not going to go through it. Obviously, you'd see in this case we would multiply both of these by 36 all the way through the equation. Um, Although I'm not going to work through that example because we've done that enough in class with the circle and the ellipse. The same thing's happening here. You're going to be completing the square. Obviously, you do not have to complete the square for the x's in this case, only the y's because I see the linear y term. Now, I will say this, that being negative is going to cause a few problems for you, so be careful as you do use your b squared over 4a trick, just like you did before. Um, and we'll work in class on changing this and doing all that completing the square stuff. But it'll be a little bit more challenging than the ellipse, but I'm sure you're more than capable of the challenge.